Bamfordrose, and another question of the week.
This week I'm going to talk about aftermarket V8 Vantage exhaust manifolds. This is a question that I've seen lots of times. It often goes along the lines of someone writing on a forum saying, hey, well, there's a few different places that you can buy these. Are they all the same? Do they all do the same thing? And then depending on the place that this subject is being spoken about, maybe there's some vendors of each system that comes on, and maybe there's some customers, there's some informed ones, and there are ill-informed ones making statements from no particular piece of data. So I want to put my thoughts to it. Take them or leave them, up to you. First thing is, there's probably three places you can buy exhaust manifolds for V8 from. We're one vendor. There's a company called Top Gear, that's another one, and there's a company called Velocity. So on each one of the three, I think we're the only ones where you can find actual, tangible, real photos of where they're made. Okay, so here's our fabrication shop. Obviously, if you've been on a lot of our social media or our website, then you're used to seeing what our fab shop looks like. And you know, they're made on site, made in the UK, made by us, fitted by us. Quality control, fitment, absolutely everything. Performance, sign off, absolutely everything, all under one roof. For the other two vendors, I've never ever seen a tangible picture of where they've been making a V8 manifold. That's because I should imagine it's somewhere in Eastern Europe somewhere. The next is the manifolds themselves. So people are saying, right, well, are the performance results the same? And some people pop up and say, well, you know, they're not made with the right collector order, or the primary pipe diameter, secondary pipe diameter is a bit small. And people that make that comment, yeah, it's true, but I've never seen a properly designed V8 exhaust manifold from any vendor. And we've seen them here because we often get the cars delivered here when the customer has fitted the upgrade and the performance doesn't meet their expectation. In those cases, we take off the other aftermarket kit, put ours on, and the customer is wowed. So we'll go through the reasons why now. I'll just flash up a few pictures of our exhaust manifold. We make them in any style. For some motorsport applications, we've used merge collectors. I've not really seen the difference in performance between a merge collector and a press collector. It's a very small distance, and if the volume is big enough anyway, whatever collector it is not playing too much of a crucial role in terms of aiding performance. It's just that the merge collector is more motorsporty, and that's what the motorsport world uses because it buys this collector that's already formed. Whereas actually, if you can make the collector yourself, you can get it for a cheaper price and it does the same job. So anyone saying, oh, well, that's a merge collector versus a press collector, there's no real difference in it. We've made the exhaust manifolds in the configuration of firing order to aid scavenging. We've also made it so it's not, and again on the dyno stin, absolutely no difference really whatsoever in tangible, measurable performance. So I don't rate the design of collector either merged or pressed, or the configuration of the primary pipes into the collector in firing order. I don't really rate any of those as significant. What is significant is the length of the primary pipe and internal diameter, therefore volume of gas that it can hold before it expels the gas, pushes the gas into the collector. And obviously the collector volume is important, and the secondary pipe length, diameter, therefore volume is important too. So what we can do now is flash up some pictures of our manifolds side by side someone else's. First picture there has got them both on the table, and immediately you can see from that picture ours is in the foreground, the other one is in the background. You can see that we maintain absolutely perfect centerline radius going through every single bend. Now if you look at the primary pipe for what's it going to be, cylinder 5, so this is going to be the primary pipe in the top left hand corner of your picture, and the primary pipe on the manifold in the background for cylinder 8, you're going to see that that centerline radius as it goes through those bends is not true and consistent. This means that instead of the entire internal diameter of the pipe nicely flowing gas, it's going to be somewhat closed, shut off, because the bend is not following a consistent center line. Next thing, we can look at a picture of the collector. There's clearly a choke point of the primary pipe going into the collector on that particular system versus what you can see on our pipe, which is a nice consistent diameter going through the whole collector. We now put vernier on our primary pipe, and we measure their 43.6 mil outside diameter, and on the other one 41.37 outside diameter. Now, the pipe used at the grade of steel that is wise to use means about 1.5 millimeter thickness pipe. So by the time you take that away from your 41 that they've used, that's super small primary length. So that's why performance on that manifold feels choked at the top end compared to ours. It's because as the engine is revving through 5, 6, 7, 7,500 RPM, certainly when it gets to 6, 6.5, it's choked because that diameter is too small. Next is we get these nasty looking instruments out and measure the neck, the opening of the primary pipe from the flange, and we record a 38.13 on the other set of manifolds, and you can see the picture where we've done the same on ours, and now we are 41. So our internal pipe diameter is larger than their external pipe diameter. Significant measurements these are in terms of affecting how the engine is going to breathe. Next we come on to the actual detail of the entry into the primary pipe, and there's pretty nasty welding going on the inside there. So it's small diameter and it's interrupted by an unsmooth surface, where you can see the shot of ours now. The welding on the inside is as neat as the welding on the outside. This is because it's been properly purge welded, and if it's been not properly purge welded, it's going to be susceptible to cracking due to contamination at weld at the point of manufacture. So not only is this not the best performance it could be, it's also compromising longevity of the part. Next picture we flash up here, this is the internal detail of our collector, and we've got a nozzle which sort of acts to accelerate gas speed as it's coming out, which in turn scavenges out the next gas in turn. And we've got a really big nozzle on ours, and you can see from the picture of the other set that in comparison it's not a nozzle at all. I don't know what that's doing. It's certainly not going to aid speed of gas flow and promote a scavenging effect. A couple of pictures now just on different angles in the manifold. You can see ours, we maintain really nice consistent centerline radius, and you can see there on this picture of the other manifold that as the primary pipe immediately comes out of the flange, that first bend there is pretty nasty. Then there's that long straight section, and again as that sweeps under the other pipes there, it's not maintaining a consistent centerline radius. So the internal diameter is being closed off, made less because of an inconsistent centerline radius from a primary pipe which was already too small a diameter. Next, the catalysts. I'd have to sack the fabricator if these were ours. That's pretty atrocious welding. It's not going to fail. this just doesn't look too nice. It doesn't look symmetric. It's not. You can see there that as the cone comes out into the exit pipe, it's not symmetrical. And the big one here, final shot, you can see the diameter of the air catalyst. So I just have to zoom in myself. The vernier there is set at the diameter of our catalyst, which is 107 millimeters. You can visually see how big our catalyst is compared to that one. Again, combined with the small primary pipe diameter, this is going to significantly affect gas flow. I've driven all of these cars that came here myself that had this kit taken off and ours put on. When you get to 6,000 RPM with our kit, it's not like a two-stroke motorbike, it's nowhere near it, but it's as if the engine is coming into a second breath of air and you almost get that two-stroke sort of power band affair. When I drive these cars, it's strangulated. The engine is not free revving up to the red line, and as opposed to a standard car, take that for a run down the road, there really is no performance difference. So, there's lots of people there that say, well, a manifold is a manifold is a manifold. It gets rid of the catalyst. They're all of similar design. It makes no difference which one you have. Beg to differ. Attention is in detail. Hope you found that useful. If you'd like to give us a comment, subscribe, hit the bell for notifications, it really helps us out.